So this one is assignment related to the waves. You can also use chat screen annotation to answer these questions. Which of the following does not apply to sound waves? They transmit energy, they can travel faster in vacuum. They results from vibration, they are longitudinal. So which does not apply for the sound waves? B, actually, because sound waves cannot like they cannot travel through vacuum, so how they will be faster? Two coherent sources. Coherent sources means they have a constant phase relation. Emits the wavelength of a lambda in phase at a point where the two meets, they have a phase difference of 90. So if the phase difference is 90, what does it mean? If one wave is like this, the other wave, this will be a phase difference of 90. So how much of the wave difference is there in terms of wavelength when there's a 90 difference is there? Because one complete wave is 360, 0, 90, 180, 270, 360. So if we have a difference of a quarter of the wave, so it will be lambda by 4. In terms of wavelength, the difference will be lambda by 4. The diagram shows a wave of different wavelengths approaches slit at different widths. In which diagram the greatest diffraction? Maximum diffraction happen or occur when wavelength is approximately equals to gap size. Here the wavelengths are very short compared to gap size. Here the wavelength and the gap size approximately equal. Here again the wavelength is much shorter than the gap size, and here also the wavelength is much shorter than the gap size. So which one we have a maximum diffraction? So B will have a maximum diffraction, because maximum diffraction occur or happen when the wavelength is equals to gap size. Question 4. When a fire engine moves away from an observer, the pitch or the frequency observed decreases. This is because this is a Doppler effect. Doppler effect means relative change in frequency when the observer or source moving towards or away from each other. So if the source is moving away from the observer, the frequency, the number of waves with that will receive will become longer, like the wavelength increases and the frequency will decrease. But why this happen? The wavelength of a sound wave decrease. Look, wavelength of a wave is not decreasing. What approaches or what appear has decreased. So wavelength, the speed of a fire engine increases, the frequency of siren decrease, the distance between each wavefront increase. As the distance between each wavefront increases, as it is going away from us, so the distance between each wavefront which we receive will get bigger. So the wavelength is in, that's why D is the right answer. Wavelength of a sound decrease or wavelength of a sound increase should not be right answer, because the wavelength of a sound is not changing. The wavelength which we receive, that has changed. So that is the apparent change. Why not C? Frequency of a siren decreases. That I mentioned. Frequency of the siren is not decreasing. Why? Because, say example, the source is emitting out 10 hertz, or it should be inaudible, say example 30 hertz. But what the observer will receive less than 30 hertz, observer will receive 25 hertz or less than that. So speed or the frequency of a sound has not decreased. The frequency which is received by the observer has decreased. So the frequency of a siren is not decreasing. It remains same. But the frequency observed by the person or observer, that has decreased. If this was frequency of the observer decreases, then it should be correct. But not the siren. Source is not changing its frequency. It is just an apparent change due to a relative motion of the source and observer. Is it clear? In question 5, the diagram shows the shape of a wave on the surface of a water of a tank at an instant. On the diagram, mark a point on the water surface whose motion is exactly 180 out of phase with x and label that as point A. So we need 180-degree out of phase. If I label this, like this will be 0, this will be 90, this will be 180, this will be 270, this will be 360, and this will be, like, further addition will be there, 360 plus 90, so it will be 450, and 450 plus 90, that will be 540. So this is approximately what, like, it is between 90 and 180. So we want the position of the wave, like we have to mark on this wave. 180 means half wavelength. So which point will be approximately half wavelength? If you measure this length in terms of wavelength, you can also answer. So if you measure this length, example, say this length was 4 centimeter. 180-degree out of phase means we need half wavelength. So 4 centimeters is the total wavelength. So which point is 2 centimeter from x? When we measure the distance 2 centimeter from x and mark on this, that will be the half wavelength. Because 180 out of phase means, like, lambda by, the part difference is half of wavelength, or lambda by 2. Draw an arrow at point Y to show the direction in which the water wave at Y is moving. Look, this is a progressive wave. How progressive wave means it will continuously move. So if this is a starting position, then new position of a wave will be like this. So if we want to complete the position, so the blue line which I drew, so the new position of a y will be here. So y is going down, and new position of x will be up. So x is going up. So for a progressive wave, how to draw the direction of the motion of the particles? For a standing wave, we can directly do on the wave. But for a progressive, how it should be done? So example, if this is one wave and you want to continue, so draw another wave. So if this was point A, what is the new position of A? It will be here. If this was point B, what is the new position of point B? Here. So A is moving down, B is going up. And same way, if we have a wave and we want, the points are there, like example, point X is there and point Y is there. And the question is, draw an arrow to show which direction they will move. So you will draw a progressive wave, like roughly sketch the same wavelength. So the new position of X will be here and the new position of Y should be down. So the position of a Y, it should point downward. Mark a point on the water surface that is rest with an instant, label this point as B. So because at the maximum, when, like, it is at the maximum displacement, the wave, for a continuous wave, the maximum displacement point, like example, B can be this or this, because momentarily it will stop at the extreme position. So whenever you want to mark the position for a wave, for a continuous wave or a moving wave, the points where the instant it will stop, so that should be the extreme position. But if the same question was there about the standing wave, like this is a standing wave, and they say mark a position where the particles are stationary or instant, they are not moving. So that, for a standing wave, we mark the nodes. So there's a difference when you mark the point for standing waves and for continuous waves. So continuous wave, the position or the points which are stationary, that are the extreme ones. But for a standing wave, the mean positions or the nodes are the points of stationary. So in part A, what we have to do, we have to Draw a wave, like a point on the wave which is 180, exactly 180 out of phase. So how it can be done? I'll give different examples. See, if this was a wave, and they say this is point A. So this is point A. We want to mark a point which is 90-degree out of phase. So if we want to mark a point which is 90-degree out of phase, so what will happen for a 90-degree out of phase in terms of wavelength? Because one complete wavelength is 360 degrees. So 90-degree, how much in terms of wavelength? So it means it will be a quarter of the wavelength. So we measure the length of the wave. Example, this length is say 6 centimeter. So if the wavelength is 6 centimeter, what will be the quarter of the wave? So 6 divided by 4, that is equals to 1.5 centimeter. So from this point, 1.5 centimeter, we'll get another point, and we mark that as 90-degree out of phase. If it is 180, so when we have a one complete wave, and they ask, like example, point A is there, and we want to mark a point which is 90-degree out of phase. So 90-degree means in terms of wavelength, it will be quarter. So first we'll measure the length of this wave. Example, length of a wave is 6 centimeter. So what is the lambda by 4? So lambda by 4, 6 by 4, that is equals 6 by 4, that is equals to 1.5 centimeter. So we'll measure from this point 1.5 centimeter, and we mark another point X. Is it clear? So same way, if we want to mark half of wavelength, we'll mark accordingly. In question 6, a student look at the sunlight which is reflected of the puddle. She puts a polarizing in front of her glasses. She rotate, and the puddle appear dark in light. Explain this observation. So what actually happened? The light which is reflected from the puddle is actually polarized light, or partially polarized. So light from the sun is unpolarized light, but the light which is bounce off, that is polarized light, partially polarized light. And she's using a polarizing filter, sunglasses. So what will happen when the polarizing filter are like the plane are parallel to the component, then they allow the light to pass, so we'll able to see. But when they are 90-degree or perpendicular, so it will appear dark. Like as we rotate this polarizing filter, if it is 90-degree, there will be no light. But if it is parallel, then it will allow the light to pass. So how the marks are distributed, one point you will mention the light from the sun is unpolarized, but when it is reflected, it causes a polarization. And that polarized light passing through a polarizing filter, if the planes are parallel, it allow the light to pass through. And if the planes are perpendicular or 90-degree, then it will appear dark or no light will be observed. In question 7, two students demonstrate the standing wave. So how standing waves are produced? The two waves traveling in opposite direction, they will give rise to a standing wave. In the class, using a rope, the diagram shows appearance of a standing wave on the rope at one instant. So if you want to complete a standing wave, that's how it will be. Mark the position, one node on the diagram. So where we'll have a node. So this will be a node, or this might be a node, and label that as N. Draw an arrow at point X to show the direction in which X is about to move, and draw an arrow to show direction of Y and Z are moving. So which direction, this is about the standing wave. So in a standing wave, they always try to move towards the mean position. So where the Y will move, the arrow for the Y, what will the mean position, the center position? So for Y, it will be towards the mean position, and Z, it will be towards them. So Y, the arrow will point up, and Z, the arrow will point down. But what if it was a question related to continuous wave? Like they said, it is a continuous wave. What if it was a continuous wave and they say draw an arrow to show the direction? So how to do that? You will draw the wave, the same wavelength, try to draw the wave, similar, same wavelength. So then how the Y will move? The Y will move down, and where the Z will move, that also move down. If it was a continuous wave. But for standing wave, they always tend to move towards the mean position. Is it clear, this idea about how to label the point for standing and for continuous waves? Then the frequency of a vibration shown is 1.5 hertz when the rope uh, is vibrating with its fundamental, with one antinode. Calculate the fundamental frequency. So what is the relation? That Fn is equals to Nf1, means the fundamental, the frequency of number of the loops or nodes is n times the original one. So if it is Fn divided by n will give us the first frequency. This is for 3 loops. So frequency for 3 loops is 1.5. And how many loops are there? So 1.5 divided by 3. So the fundamental frequency will be 0.5 hertz. Because for a standing wave in a rope, the frequency for 3 loops is equals to 3 times fundamental. Frequency for 4 loops is 4 times the fundamental. So frequency for nth loop is n times the fundamental. So these are 7 questions from wave assignment.